everybody doing? Everybody else healthy around here? All right. Okay. Sure. Extra 3. Add 2. In the exercises? Okay. Sorry for being a little discombobulated. Okay, so how is everybody going to finish today? Oh, I am on. Oh, good. So is everybody working on their lab? So did you guys stay? Did you hang out in here during lab time or not? Was it fun? Yeah. You were on. Okay. Did you help each other? I mean, did you guys help each other if you got stuck? Yeah, but some of you weren't here because you didn't get the whole disk drive thing was a bit of a mystery. I didn't realize you guys don't have. Oh, okay. So you figured out how to share. Kindergarten lesson retaught. But you guys did. You have all work 4 through 6, and now on the actual lab assignment.
Little fun.
help. Okay. Okay. Yeah. I was sorry about Thursday not to be here to help you guys work through that, but I think the best way for you to learn GIS is to actually have to struggle through all of these problems. And once you figure out how to do an analysis, it gets easier and easier every time. So that's my my pep talk for you. But why don't we? You guys all seem a little concerned about lab. Do you want me to spend a few minutes on lab right now before we start lecture? Is everyone just staring at their labs right now? So maybe I need to. So what are you guys stuck on?
Okay, so I think if I don't know why I had it in my head to do county, but I think if I do states and do exactly what I did, it'll work.
Yes.
Yeah?
Yeah, you definitely want to do states, not counties.
Okay.
You probably are doing counties because that was the, in the lab assignment, that was,
Yeah, no.
that was the file that was in there.
I just blew it on that one, but I'm going to fix that right now.
Okay, so you're trying, are you working on the chapters still?
Yeah.
Okay.
Yeah, that was the lab, right?
The chapters, and then I posted an assignment to do, you use what you learned in the chapters to do another analysis of.
Oh, okay. Because last time I checked, it was like you were still working on trying to get it up or something.
No, it should be up under, no, that's the quiz.
Okay.
I can't get the quizzes to work. Yeah, so I sent a message to help to try to get help for it, but
so
for now we're.
We had the 2 chapters, a lab, and
You guys all saw your assignments for lab are going to be posted in that lab folder under resources, and so there's an assignment posted there that says lab 2, which is going to have you go through the exercises an exercise similar to what you did in chapters 4 through 6. Yeah.
Yeah, that's what I was trying to do here.
4 through 6. Yeah.
Okay.
So you have to do that first so you understand how to do the process.
I'll get that. Yeah.
Okay.
I think I got it now. I'm just doing county for some reason.
Okay. Okay. Yes.
It's super small and spit out because you have like Alaska and
Right.
is that okay, or
Let's focus on the continental U.S.
okay.
Yeah. Let's not. Yeah. Alaska and Hawaii aren't that interesting in it anyway. No need for Puerto Rico or anything else. We'll just focus on the continuous United States. I don't want the state names. Yeah, I think that's going to be messy. Why don't I'm going to go through some slides on map layout and stuff. So before if you guys have questions on layout, let's do that first. Okay.
So for the graduate degrees and higher, there's a huge margin of difference between this one. There's only one 32.4, and then all the rest are really low. So if I have the mean at 11.1, all the states are white, basically.
So there's different ways to stretch your data too. If you go under, you can play around under natural breaks. If you do that, you can look at different ways to display it. So one of the things I want you to look at is different ways that you can separate your data to make it display better, to emphasize what you guys think is the most interesting component of that data. Is it that there's one that's way off the chart, or is it the spread in the middle, or you guys can do it the way you want to do it. Okay. Are you okay, Andrew? Okay. You guys okay? All right. Okay, for the sake of getting caught up a little bit, let's get to the lecture, and then I can stay for a little bit after. If you guys have time, we can work through some of the questions, okay? Because we're still at, I'm going to talk here. Okay, we're still at lecture 3. We left that one early. Okay. So we'll try to go through this kind of quickly, but it's worth talking a little bit more about vector data. Everybody here? Okay, we'll go through this quickly. As you guys remember, we're working just with one component of this larger entity of ArcGIS. We're working with the desktop GIS, and even within that, we're not working with all of the licensing. These are the ones we are working with: ArcMap, which is what we're most commonly using, our actual mapping displaying program. And we're also working with ArcCatalog and ArcToolbox. These are just the icons, so we had these slides in our last lecture. So, and we'll add extensions on. You can buy separate extensions depending upon what kind of analysis you are working on mostly within Esri. We have spatial analyst, I know, and I think we have network analysts. We'll check on that later. But for some people who are only working with very specific types of analysis, they can buy special extensions instead of having to get a whole new license for, say, Arc Editor, which is the next one up. You guys know this now. You're becoming experts in how you add your different ways that you add your map layers to your documents. So I can just race through this. So there's a lot of different types of data that you can use in ArcMap, open in ArcMap. And this is just showing you in that catalog tree what some of them look like. The most common types of data we'll go through in more detail, which geodatabases are, we'll talk more about that, coverages. You've seen Arc layers and Arc image files. This is a raster file, which we won't use very much in Arc because it's not native to Arc. It doesn't work quite as well. A tin is somewhere between a raster and a vector. It's an interpolated surface where instead of having a continuous surface, you have sampled points and then you create a surface from that. So it's a little bit different from a raster, but it's also not really the native format of Esri. ArcMap documents, which you are probably now familiar with as well, tables, and then of course shapefiles, arc scenes, coverages. These are all things you can see within and open within your program. So the most common data types that we'll use and that most people use in ArcMap are geodatabases, coverages, and shapefiles. These are the different icons for them, and we're going to go through each one of them in turn. Shapefiles are probably the most, sorry guys, okay, the most commonly known file format. It's what you guys have already been working with a lot. It's kind of a industry standard. People share shapefiles all the time, or if you talk about GIS files, sometimes people just think of shapefiles. But shapefiles are not the only kind of file. And they're not actually the oldest kind of file, but they're sort of a more simple file because they're non-topological, which means that there's no topology information stored in shapefiles. You guys remember topology from last week? All those rules about the relationships between objects. So you can have a shapefile where your polygons can overlap. There aren't rules about that, which is sometimes a really good, handy thing if you're have objects that you need to overlap, and sometimes it's a messy thing if you're working with, say, property boundaries, and you can have a property dispute because you've got two polygons that overlap. But that's neither here nor there. Shapefiles are non-topological. They don't have rules of topology associated with them. You are familiar now with these different types of geometries of shapefiles: points, lines, polygons. That's how everything is stored inside of shapefiles. Because there is no topological information associated with shapefiles, it can mean that it can be simpler to read them, to do processing on them, because there's not all this extra data associated with them. And it also means that they can have, like I said, overlapping polygons, features within a shapefile that can overlap. Features don't have to be continuous. So sometimes those are good things. It's that simplicity and that the less disk space and the simplicity of the file structure, I think that's caused shapefiles to become that standard. You can email someone shapefiles pretty easily. When you have a shapefile, you always have at least 3 files associated with it. You guys notice that when you look at your folders? You always have an SHP file, which is the main sort of geography file that you're loading, a database file that holds all the attribute information, a DBS file, and your index file, the SHX file. If you don't have one of those, you can't open your shapefile. You always have to have the 3 of them together. They always all have to have exactly the same file name. So if you were to go in and you were trying to mess around with the name of your shapefile when you were in your folder, and you changed the name of one of them, then you wouldn't be able to open them. So if you ever want to change names of your shapefile, do it inside of Esri. Do it inside of ArcMap. Don't do it in your folder, because you could end up making a mess of your data. Okay. The database file contains all of that information about the data, all of the spatial information that you need in order to read your the main file. And the index file, it's not really that important for you guys to know this, but it just has some more of the how the file gets read. Shapefiles store a single feature class. So you've got a point file, you've got a line file, or you've got a polygon file. You don't have all of them together. You have information about what the kind of shape is. This is stored within your attribute table, and then it reads over to your database table that stores all of that other information. Okay, so, and when you look at a shapefile inside of your catalog, this is looking at the catalog view, which shows you how all of those files are going to appear within your program and how they're all stored together. So here you're looking at all of the different types of shapefiles and the icons you'll see with them. I know that's kind of hard to read that. It's not that critical, but you guys can go back and look at that more closely if you would like to. I'll also say that this also shows CAD files. So you can read CAD files inside of ArcMap. CAD files are more commonly used in like architecture. We won't be working with them at all. Okay, so coverages are actually the older, the first Esri file that they use for coverages. Coverages do have topological information with them. They're kind of, remember that 2D rule where you have planar topology, you can't have overlaps. Coverages have that rule associated with them typically, so they're 2D. You can't have overlaps within your features. Coverages also have both your primary information that we're thinking about, like your points, your lines, your polygons, but there's also secondary features that get stored, like ticks, which are sort of points along the way that are measuring, that have spatial information on it. It's not a point specifically, but it has spatial information associated with it. Different features like map extent, how big of an area is being mapped. Annotation, say labels and things associated with it. So all of that can be stored in a coverage. That doesn't get stored in a shapefile. And when we talk about coverages, we also talk about sort of a group of associated data. So you'll have kind of themes, a whole group such as soils. All of your soil data might be stored in a coverage. Or you might have a whole area that's stored in different types of coverages together. So you'd have like a polygon for a lake and a set of streams. So those could all be stored in separate coverages and then could be grouped together. So this is just showing how in coverage you have different types of data that can be stored. If you see, this is a whole group, a collection of coverages here under vegetation, where you have different feature classes together that are going to be stored, and then they could get all drawn together when you open your coverage, your collection of coverages there. The point here is just that your attribute data is actually stored in a different type of database, not the same as in a shapefile. And again, that there's topology information associated with a coverage. So you actually have to build topology information, and you do that within. You can have a separate toolbox that you use to build the rules of the topology when you make a coverage. And that topology, again, establishes the spatial relationships, and it also establishes things like direction, for instance. So not only how things are associated, but the way things flow, as an example. The nice thing here with coverages is that when you change some of your data, say you went in and you edited some of your features, all of that information gets updated inside of the attribute table. That doesn't necessarily happen in shapefiles. You actually have to go back in and recalculate things like area if you go in and you edit a shapefile. So this is just showing you an example, again, of a whole group of coverages here. This is the icon for the coverage, and then all of the different features that are stored within that. So you've got points and arcs, routes. So all of this data can get stored together. And then the last thing we'll talk about are geodatabases. So geodatabases are a way that we of our data together. You can create your own topology rules within a geodatabase. You can store all of your, here you've got, for example, all of your water features are going to be stored together. And so they have relationships to one another. So you can have topological relationships within your shapefiles, and then you can have relationships between them. When you start working with larger databases, it's better to work within geodatabases to store everything together and keep all of your rules and layers consistent. Again, when people want to share data with you, they're typically not going to send you a geodatabase. They're typically going to send you. So geodatabases are a newer version and a sort of a more elaborate way to kind of keep data organized and cleaner. So topology we've talked about before. Again, it's going to keep your data quality high. It's going to make sure that you don't have errors or overlaps that you don't want to have, and it's going to make sure that when you're working with that data, that you're not going to create new errors inside of it. What that geodatabase looks like, you have the extension NDB, that's a geodatabase extension. And here you can see this icon here is your geodatabase icon, and then you can have all of the different kinds of data stored within it. So you can have raster data sets inside of your geodatabase, points, lines, polygons, and you can also have a whole feature data set within it. So what that does is it just makes sure that everything is working together, that the integrity of your data is the same. You're not going to end up with problems when you're overlaying them, or if you're editing one, you're not going to create new errors. Does that make sense? Okay. And here, just to show you that the topology actually can be stored as a separate set of information within your geodatabase. So just to show what that looks like, it's kind of this container as an idea where you're storing all of your data together, and you're making sure that it's all going to work nicely together. It's all going to play nicely. That'll make more sense later when we get to problems with like projection and overlaying data and problems that you can have. And again, when you're working inside of a geodatabase, these categories here within your shapefiles are always going to be updated automatically. Whereas if you were working in just with shapefiles and you did editing, or you did projections and changed your data, these areas are not going to be updated. So that's just sort of a word of warning. Always go back and recalculate your areas if you're working just with shapefiles. Yes.
It sounds like the geodatabase is better creates cleaner data.
Yes.
So other than what you mentioned with somebody sends you a shapefile and you bring it into data, what would be any advantages to working with shapefiles over the geodatabase?
It's really the simplicity of it. That, as I said, people will send you a shapefile. You can just work with it right away. A geodatabase, you have to, sometimes if you have to make edits to it, you have to work within ARC catalog instead of working just in ArcMap. And also for translation between software programs, you can open a shapefile or import a shapefile, but you can't import a geodatabase. You have to split it all apart and take it piece by piece. So I guess that the geodatabase was also built so that some of the, if people are working with different programming languages, you can work more easily with a geodatabase as opposed to shapefiles. So it's much more complicated and it has a lot of advantages, but it really hasn't been adopted as like the industry standard. The shapefile is still the industry standard. Okay. So just again to go over some of those things, a feature class is a collection of features of the same type, like we've looked at a number of times. You can collect all of those feature classes together in a feature data set. And a geodatabase can hold all of those feature data sets together. A geodatabase can also hold just straight shapefiles. They don't have to be grouped into a data set. Just when you thought you understood shapefiles, right? I'm going to throw some more things at you. So this is just an example of, in a coverage, how we have, I mentioned those things like ticks. So this is just showing you a tick. It's not actual data, but it's showing you like the extent of your map here. And arc information just in your lines, annotation. So these are the kinds of things that get stored in the coverage that don't get stored in a shapefile. Okay. So again, the most common data types that you guys will be working with in ArcMap are shapefiles, because everybody does, coverages, and geodatabases. So we'll go into working with geodatabases more, I guess it'll probably be next Tuesday when we'll start looking at creating those. And something to point out is that like the spatial structure of these files is all different. Shapefiles, as I mentioned, they don't have any topological structure associated with them. They're much simpler. Coverages do have topological information, and you have to build the topological information either with Toolbox. We don't have a workstation license, so we just would work with toolboxes. And geodatabases have the advantage that you can create custom topological rules with them. And what this means is with this build and clean tools is that when you're working with coverages and you're doing editing, you might put a lot of points in when you're building your data, and then you go through a process of cleaning that data where it goes through and removes unnecessary points and tries to make sure that all of the topological rules are being followed within your data. So it's a process of editing that you go through. Okay, again, just another view of that slide where I'm showing you that there are even more types of data that you can work with inside of ArcMap, but we won't work with them too much in this class. Rasters, layer files, CAD drawings, and different tables you'll see. And as I mentioned already, when you are working with shapefiles, you always have to have these 3 extensions. So if you have a roads shapefile, make sure you have the SHP, the SHX, and the DBF extension. You can see those when you look with Windows Explorer, but if you're going to copy or edit them, it's always better to work in Arc Catalog or use a tool within ArcMap so that you don't make a mistake when you're doing it. If you're outside of ArcMap, just make sure that you get all of those files. Okay, so I think that's the end of, lecture 3. And now, if you guys, there's lecture Oh, I didn't add it yet. Let me add lecture 4. Oh, I don't think I'm not on my computer. Hold on a second. Let me save it. Are you guys following along on your computers? You like that? Okay, great. Okay, so one thing that you will always be doing when you're working with GIS is making maps. So making sure that you represent data well is pretty important because there's good ways to represent data and there's bad ways to represent data. And I guess just being a geographer, really like looking at maps. I really like looking at old maps in the days before GIS to think about when people were doing this all just with pen and paper. Pretty fascinating. Yeah. So this is an old map from 1930, just showing the population of states, trying to represent that with size. Like the markets are people symbol up here, because this is all about, how can they market better to people. It's probably would be pretty cool to look at how populations have changed too. I'm sure that this one, for instance, is a lot bigger now than it was in 1930. That was before air conditioning, I think, 1930, maybe. Or actually, the whole Sun Belt down here would be really different. And I don't know. I guess Chicago's pretty big. You guys could do that. You could make a map now that you have all the census data at your fingertips. All right. So I'm going to talk a little bit. I'm going to start with map presentation because I think you guys are making maps. You need to know some of those sort of key elements that you need to include and things to think about in your map layouts. And then depending upon how much time we have, we'll get into scale and how to represent different data sets, different types of data with your maps, how you can do that. Okay, so data representation, whenever you are working with maps and visually presenting data, thinking about how you're representing that data is important. And some of the sort of may seem like fundamental things, but the kinds of colors that you're using are important, or the fonts, or all these things end up portraying or trying to, how you're portraying your data is really important in how people are going to perceive it. So we're going to talk about the map design process. And I think it's definitely partially based in art and our understanding of things like color, but it also you need to think about how that is communicating information to other people. So as you're starting out making your maps, you always need to think about what your objective is. Who is going to be looking at this map? What kind of information are you trying to get across? What's the purpose of it? So you always need to start out with that. What's the big objective, and to keep that in your mind as you go forward. Obviously, you need to think about the kinds of data layers that need to be included. What's the purpose? What's the primary purpose of your data? So then you need to think about the most important data layers that need to be included. Sometimes you can end up with a lot of data and it can be confusing. What should you really be focusing on? And then plan a layout for it, choosing different colors and symbols. Again, emphasis, you need to think about how colors are going to cause things to be emphasized differently, what sort of details, and then go back through a process of looking at what you've done and revising it depending upon how, maybe how it looks after you've been sort of focused on it for a long time. Come back to it and look at it again. always edit it, check for spelling, things like this. And then finally, you have to think about what the final output of your map is. If you're going to be printing it out on just a basic printer, think about how the quality is going to come through. Are you going to lose some of those finer details, or are you going to have it up on a big screen so you can put a lot more of those details in it? Okay, so going through those each, you can go back and refer to these slides when you're going through your map making process, but think about the uses of your map always. Think about who might be using your map. You know, is there sensitive information in it? That's always something to be very careful about. If it's private information, obviously you shouldn't put it in a map that can be distributed widely. And thinking about things like what should be highlighted in your map. As I said, how is it going to be displayed? So think about things like the size of your text for the displaying. Here's an example of maybe where you've put too many data layers inside of your map. The map on the top, you can't even really see what these points are lost because the background information is in there. So avoid putting unnecessary information in your maps, even if you think it looks pretty. If you're losing the message, then it's not helpful. But sometimes other layers can help, like in this one, for instance, you really need, it's helpful to see these different polygons so you have some sort of orientation, or the rivers, or those can help orient your audience. Okay. So you guys experienced this last week. Your layout matters if you're going to go horizontal or vertical. Obviously, with something like the whole United States, going with a landscape layout is much more preferable to going with this portrait layout, where all of your data is getting squished. What happens is you're ending up with all these odd empty spaces. You never want to have empty spaces in your maps, or big empty spaces. Remember that Z from the book where it shows you how people are going to read your map? Fill in your title and your legend, make sure everything is kind of balanced. This is something I saw in a lot of maps, is this the size of your elements needs to be kept proportional. Here you've got a really, really big scale bar, and it's not it's out of proportion to the US. Whereas over here you can see it's much more in proportion to the other features in the map. May seem kind of obvious, but what you want to think about is how that's causing a strange emphasis to happen when you're reading it. You're seeing that huge scale bar, or the legend here is too large. These are called neat lines, the ones that go around the outside, which are a nice feature to add. But if they can also be detracting from your map. They need to be aligned well. So balance and symmetry in your maps, you should always think about how all of the features are fitting together so that they're reading well. This is an example here where you have well, this is actually a poor balance because everything is way too aligned to one side, whereas here it's not symmetrical, but it's much more balanced in the middle. So here, sometimes symmetry helps keep things balanced, and I guess this one, things are asymmetrical because this element is balanced to this, is aligned to this side, and this balance is aligned to that side. So sometimes it doesn't have to be, you're not always, there's no hard and fast rule is the point. You have to look at it and see what balances your map better. Okay. Now this is probably the most important slide from today, or at least from map layout. All maps must have certain features. If you don't have these features, you aren't giving the critical pieces of information to your reader. So you always have to have a title, so name your map, and that should be not massive, it shouldn't overpower your map, but it should be very clear, it should be simple. You should have a legend And make sure in your legend that somebody who's looking at your map for the first time knows what your legend is about. So make sure that there's a name, a title on your legend, that those features are named well. Again, it shouldn't be overpowering of your map. It's just something that your reader needs to be able to look to. Your scale bar has to be there. Make sure that the units of your scale bar are useful to your reader. If you're working with someone from the US, you can use miles. If you're working with a European, you probably want to use kilometers or meters. Decimal degree is not such a great unit because most people don't think in decimal degrees. The elements that are here in blue are the ones that have to be included. We haven't talked, or we didn't talk last week about this concept of sources and credits, but it was in the book. You always want to make sure that you put a box in your map that says where the data is from, who made the data. Put your authorship in there as well. And the other thing that you need to put in that sources and credit is what's the projection system of your map. So we'll get to that in our next class. We'll start talking about projections, but is it in lat long, for instance? Is it in a UTM coordinate system? That can be really important information for your reader. I always like a north arrow in my map as well. It's not as critical, but you should have that. But these ones in blue, if you don't have these in your maps from now on, you'll be penalized for it. And it can be helpful depending upon the layout to have information like your graticule. Remember that's the lat long lines, so you can have more orientation for your reader. And these things, neat lines, like I showed you, help to define your layout. If it needs explanatory text, you can add it, but probably that can keep it simple, but make sure you have all of those critical elements. Okay, so colors and symbols. There's a lot of text on this. I think somebody didn't know what they were doing when they were making the slide. But this is all information that you guys can go back to and refer to. But make sure that you're highlighting your message with what you're choosing in your colors. So if you have a lot of different colors in your map, it can be really overwhelming. So go back and read through this, but things like too many really strong colors, it's never a good idea. This is kind of basic art thought. I don't know if any of you guys have taken art. I know one of you takes art, but some of these concepts of color and design and balance are kind of primarily taught in art. But as a map maker, you're actually putting together kind of a painting in a way. So thinking about these things is pretty important. How your use of color is important. If you're using cool colors, they're calming. Warm colors are exciting. Do you want your reader to be calmed by your map or jazzed up and excited by it? Whenever you use warm colors, they overpower the colder colors too. And always be sensitive to things like political and cultural meaning. If you're making a map of voting patterns, for instance, if you use red states and blue states, it's going to mean something to your reader if they're from the US, maybe not to somebody else. But think about those things when you're putting your maps together. Okay, so in order to create different emphasis, color is a great thing to use. As you can see here, when you're using a black and white map and then you're using these color spots, you're really emphasizing these features. So think about if you're trying to emphasize something, then including something like that color, a bright color. So here you're using the bright red to show where there's a huge number of cases. So that is your emphasis. And these pale colors or the transparent layers are de-emphasized. Another way to do that is with contrast, or with using a bolder font, for instance. This concept of symbol hierarchy, it's important to make sure that you're giving your reader information about what's more important by using some visual differentiation in your features. So here, there's no sense of if anything here is more important, but when you use this this hierarchy showing that this state or this county, whatever it is darker. It's the emphasis. You're giving your reader information about what to focus on. And again, over here, you don't have any sense of what the information, great information on this one. But what's the important feature here? Are they these? Is it information about like the landscape, or is it information about where the bodies were found? Pyramids, the bodies. Okay. Again, how we read a map is not always, it's intuitive. It's not something that we're going to kind of rationally necessarily be able to think about, but we look at something and we process it. For instance, where's water? If we see blue, we think water. We're not going to think land. So always make sure you're thinking about that when you're putting your maps together, putting the palettes together. Again, red for us tends to mean danger, but there's no real sense of what's important in these maps. So those are some bad maps. Also, visually, how we see it, aesthetically, we are going to want to look at a map, or we're not going to want to look at a map. So this is obviously far too bold. You can't tell what's going on. It causes a bit of a headache. So go through play around with your layers, see what makes the most sense. This is showing how making things transparent can help, especially if you're putting a lot of data layers together. Here's an example where working with too many different colors, you're losing the information. We kind of logically see a darker color and we know that that's representing maybe more density, or you can look at it and intuitively understand that it's trying to show you a pattern. Okay. So just basic color terms. We are always using colors in our map. Hue is just the basic color. Saturation, how dark that color is going to be. It's the intensity of the color. When you're working in different programs, there's different ways that you're playing around with your colors to create those features. Sorry, too many slides. Okay, the color wheel. You guys know the color wheel? You worked with it before. When you're choosing colors in your color wheel, if you're trying to differentiate things strongly, it's always good to work on the opposite. Work with things that are going to make the other color pop, like red and green are opposites, yellow and purple, blue and orange. That's going to make your features pop out. It's better if you're working with a lot of colors to make sure that they're equally spaced around your color wheel so that they're more balanced. They say 3 or 4. Typically, like 3 colors is about as much as you'd want to put into a map. If you're trying to show things that are harmonious and features that have a relationship to another, using things that are next to each other is better. Again, just to show that how when you're using the contrasting colors, how it makes the features pop out, versus if you're using things close to each other, it's more harmonious. Showing that in an example of a map, how those contrasting colors are really popping out. You think of them as you're trying to show objects that are very different from one another, whereas when you're using harmonious colors, they look like they have some sort of a relationship to one another. If you want to use a monochromatic color scale, so just like we were doing in your maps, I think in the example they were saying that monochromatic blue is a good color scale to use. People can differentiate a lot of colors of blue. So you go from a low to a high. That's really good for maps where you are showing a range of values along a scale. And typically, the darker that color, the more important the feature. If you use more light shades along that scale, you can people can differentiate more in the light portion of that rather than the dark portion. So this is an example where you have a monochromatic map, but it's really difficult to see what the differentiation is there. Once you add more contrast, you're better able to see that. A dichromatic scale has two colors going towards the middle. You've got just two monochromatic scales. You start with a low value in the center, and the colors increase in saturation to each side. It's a great thing to do if you're trying to show something that has like positive and negative values around 0. So it's easy for us to interpret something like that where the 0 point is white in the middle, and then you're going towards red and blue. And again here, where you're trying to show that great contrast because you're using those two contrasting colors. So it may seem kind of like a lot of basics here, but how you're making these decisions actually is showing how you can represent your data differently. Again, think about the political and cultural components when you're choosing colors. Cooler colors are calming. If you don't want things to be emphasized, warmer colors are exciting, and they're always going to overpower your cooling colors. So there's actually a whole, people take cartography classes and just focus on these components for a whole semester, and when you're trying to think about how you're going to maybe sway your audience with your map making, these are all So when you're using colors, don't just choose them willy-nilly. Think about the relationship they have to one another. Think about how your data is going to be viewed. If you're just going to be looking kind of zoomed into your map, think about using colors instead of points, for instance. This is saying that when you're using polygons in your maps, that instead of using a chloroplast map, which is this one, that it can be better to use just colored points, that we can see that better than when we have this one, where you can't really tell the difference between each one of these polygons. You can see these points better. They're using the centroid point, so when the center point of the polygon is colored instead of the entire polygon. In ArcMap, you have a lot of ways to go and change your color. Not only do you have the ones that you guys have probably all seen before, these pre-assigned ones, you can go to the advanced tools and play around with how those colors are made if you want to work with that more. So just some examples, again, of different ways that we represent data. These are obviously a little bit old now, Obama, McCain, but if we're just going to show our map in solid blues and reds, we're going to show nothing about the in-between values. Whereas here, when you show that there's a little bit more of a leaning instead of a solid, you can see that there's more variation in your data than what you're leading your reader to believe if you're just using two contrasting colors. Okay. Black and white maps are great, especially if you're just going to print them out or you're going to put them in a publication frequently. You have to pay for your color maps, so it's good to know how to work with black and white maps and how to display your data clearly with it. Frequently, it's better to work instead of just on a spectrum of white to black, to work with different patterns. You can differentiate more with these rather than just white to black. And again, the same pattern of lighter tends to mean something that we're not emphasizing. Darker tends to be what we are emphasizing in our maps. Okay, so always go back to the end when you're done with your map layout and really scrutinize it. Think about, are you really doing what you set out to do with your map? What looks like the most important feature on your map when you just look at it? Is it going to be represented well in whatever you're doing with it when it prints out, or if you're displaying it on a projector? And think about the overall layout of your map. How does it look? Is it balanced? Does anything pop out as being sloppy? Or so you can just go through the process of here's a bunch of ways that you can think about your map if you want to go through that. And then you might have to revise your data for printing depending upon what your final output is going to be. So this is just showing maps that where you're clearly going to be using a color layout for it versus a map where you're going to be using black and white. So here you can see that they've used for this map, instead of all the different colors, the different patterns in the black and whites versus just the gray scale for this one. Okay. All right. So just be sure when you're going through your own critique that you're paying attention to all of these details. For instance, this is kind of a sloppy to have the SHP component left in your legend. You go back through and clean that up. Make sure that there's space on each side of your legend. Clear intervals. They did that in your book here. Make sure like these are just not easy for a reader to look at and understand what we're trying to see. Okay. Okay. So what do you guys think? Which map do you like better, 1A or 1B? And why? Yeah, the graticule is way too overemphasized here, right? Yeah. And the contrast, right? The contrast was too great between the red and the blue here. You're trying to, it takes away from the emphasis on the land, like Jenny said. Okay, what about this one? And why?
How do you know when you have to watch it like
But yet it's obviously very important because there's a map of it that we're going to critique here. Okay, this one has a lot of balance. There's something else that's important that's included in 2A. Source, yeah. Right, and it is giving them a little bit more context. Because we didn't, well, I mean, I guess it's in this legend, but it's better to have it up here to know what we're looking at in your map. All right. What do you guys think? Which is red-blue reality. It has a cultural significance that we can all understand, right? The red and blue reality. So they're using that. Yeah, for sure, right? Because even in this top one, the red and the blue, which are contrasting, are actually essentially the same. Yeah, great. So we don't intuitively look at this and have any sense of value, right? Yeah. Okay. All right, you guys all passed. Now your maps should all be beautiful from here on out. Totally in proportion, proper use of color. I don't know. It's kind of fun. These are some resources where you can go and just play around with different color schemes. You can go and play around with different map layouts. But it's really important because when you create a map, people see it and they believe it. We just do. I don't know. I'm not exactly sure why it is, but when we see something represented spatially like that, we tend to believe what we're seeing. So always be careful with how you're portraying information. All right, so it is 12 o'clock. we can talk a little bit about scale if everybody's feeling, I think you guys are okay. I can stay for like 15 minutes after. Will that be enough for everybody who has questions on the lab? How about this? How many of you have questions on the lab? Okay. Okay, well, let's go into scale, and then I won't go into the different ways to represent data. We'll do that in the next class and go through some examples. That'll be better. Okay, so we talk about map scale a lot. In geography, we're always talking about scale. It's a really important concept, and it can mean a lot of different things. So you always have to specify when you say scale, what kind of scale are you talking about? So map scale is the ratio of the distance on the map to the distance on the ground. So you there's no units of it because it's dimensionless. You typically have it on your scale. If you don't always have it in your scale bar, but it will show you. For example, here is showing you what that ratio is. So what's the scale? In printed maps, you typically will see it, or it'll be stored in your metadata. It's also shown in ArcMap. There's a bar at the top that shows you what scale you're at when you zoom in and out. So when you're going from large scale to small scale, you have to be sure you're talking about the scale properly. So large scale means that you're zoomed way in. So you're covering a smaller area in more detail. Versus a small scale where you're covering a larger area with less detail. So depending upon what scale you're at, you have to think about the kind of data that you're able to represent in your map. There's two things that we can do when we're trying to either go between scales. If we want to reduce the information, we can generalize or we can classify. So one way to generalize is taking and reducing some of the detail. So systematically taking out some of these smaller roads in this map is a simple way of generalizing as we're going, we're zooming in here. Or classifying our map. So how are we going to show, and how that classification happens is going to display the information differently. So which way are we going to kind of reduce and clump our data together? So when you have a larger scale map, so here we're zoomed in our map, we have a larger scale map. We have less area, we have a lot more detail, so we don't have to worry as much about generalization or classification. We can put a lot more in there. And this is just showing, as you're going to go from this larger scale to a smaller scale, how you're going to have to reduce some of that information. This is an example of what you could do. Instead of becoming kind of an area of your city, you're going to go down to the size of a point. Because in your smaller scale, remember, more area, less detail, and so more generalized and more classified. The other thing that gets confusing is when we talk about scale, we can be talking about different things too. When we talk about spatial resolution in our map, we can be talking about like the pixel size. How much data are we getting in our map? And we talk about a fine scaled map as having really fine spatial resolution. So this is showing a high quality aerial image that's fine scaled. We can include lots of small objects in it, versus a coarse scaled where we're zoomed out and our pixel size is going to be much, much larger. We also talk about extent. If it's covering a large area, sometimes we might say it's a large scaled map versus a small scaled, and that's when we really might get confused. So always be clear when you're talking about scale what exactly you're talking about. another important thing to think about is the source scale of your map versus the display scale. So in GIS, the source of your data, the scale that your data was created at is critical. Remember that problem of generalization in vector data? So see this was digitized. The source scale of this is different from our display scale. So what we have is a resolution problem. So the original map, the original data, the source scale of our data is almost more important than what the display scale is, because you can just have those problems of error and alignment. You guys have any questions? Okay. And I'm going to stop there because I want to get into this next section. It's going to take longer than what we have. So we'll start from here on Thursday and do some exercises with it and then go into projections. Okay. You know, it's going to depend upon when I get the quiz. I can't access the quizzes. I'm not sure what's wrong with Sakai. I think probably what we'll do is, at this point, since it's already Tuesday, I think we might just wait and do all of them, have it start on Sunday so you guys can focus on your lab assignment for Thursday. And Sunday, I'll try to put it up earlier. I'll put it up as soon as I can, and I'll have it through Thursday's lecture. So from Thursday backwards, we'll have all of those lectures covered. And it's not high stress. I just want to make sure that you're paying attention. You guys all seem to be paying attention, but it's a better way to assess it. Okay, so if you have questions, I'll hang here. Okay. Oh wait, let me turn off my mic.